Hey, what's going on, guys? GoMonkeyKinsey here. I've just released my new JavaScript chess engine called Wukong, and in this video I would like to introduce the public API that is available along with this chess engine. So it supports kind of two interfaces. You can play versus Wukong in web browser. That's it, so it's not really that much. You can move pieces, flip board. And also you can play versus Wukong via UC protocol. In that case, you need to install Node.js, download the sources, and follow the simple instructions in order to connect your engine, say, to Arena GUI. In this case, in QChessClay, that's even more trivial. So you just need to say like Node.js, WukongJS, and that's it. So just running as a regular backend Node.js script, backend JavaScript file via Node.js. But one of the main things that kind of what makes this engine stand out is the public API that I've created that is reused by both interfaces, by the browser interface and by the console interface, basically. And also here I have some API usage examples, and in this video we'll quickly walk through this kind of functions. Well, maybe I would have dropped some along the way, not sure. But anyway, I would be demonstrating within the user interface in the browser, because most likely that you don't have Node.js yet being installed, and I just really want you to make it as easy as possible to reproduce the steps being shown in this tutorial. So I would be working on the page where we have this WukongJS public release, so you can play online versus it. So I just need to open my developer tools and pressing Ctrl+Shift-I should be both the same kind of short keys in both the Firefox and in the Chrome and the Firefox browser. And by the way, it prints like some user information to the console, which might be kind of interesting. So we would be working within the console entirely, so I will now just completely get rid of this image and the functionality as well. So all we have in the user interface is actually been described in Wukong.html file. That's the GUI file. So here we're starting with creating this simple user interface. Well, I would be doing this programmatically within the JavaScript just to make it faster and easier, and to keep this crash course going on completely in browser. So we'll create an engine instance, and then I'll just try to show you how we can play around with internal functions to manipulate the chessboard. I'm not going to be creating this on click or drag and drop bindings that are available in the GUI version, but I just want to quickly walk through the core functionality provided by the engine, starting from creating the engine instance, manipulating the appearance, and then going to manipulating the internal board state. So without further ado, let's actually start. I just need to make sure. No, it's not within the source code here. No, I actually need the source code to just see. Okay, so board size, square, select color. Okay, so let's start with document.write. So just get rid of entire image, so we have an absolutely empty document now. So in order to import Wukong as a module on the front end, we need to make sure that we have, well, obviously just document write gets rid of body tag as well, so I just quickly create this body tag. So we need actually two things. We need to create a tag which is called which has an ID equals to chessboard. Okay, and div like this, and also we need to import the script with the source equals to Wukong.js. Well, assuming that now I'm on a GitHub, so this source is aligned with the current working directory. If you're doing this locally, you may need to specify the path if you have WukongJS being located somewhere else. I obviously need to close the script tag, and And well, probably just go for a multi-line mode. And now the next thing to consider, we want to create engine instance. So we can simply say variable, let's call it engine equals to new engine, and hit enter. And now it creates the chessboard. Well, obviously you can move pieces here. It just gives an errors because this on drop or on click are not being handled properly. Also highlighting doesn't really work that nicely, but again, like, it's just the instance, so in order to make it properly you need to make sure that the GUI is created. But I don't know, maybe from the architectural perspective it's not really that great idea to have this GUI stuff within the chess engine itself, but that's how it's done now, so I just want to cover how it works at the moment. So let's start. Okay, let's clear the console and just write it again. So the next thing that we could have tried to do here, we can specify some custom parameters. Well, let's make the chessboard smaller and let's specify some weird colors for light squares, dark squares, and the select color as well. So it looks totally weird now, but at the very least it's the proof of concept that you can change the size and the appearance of the chessboard. Again, like, I'm sorry for this errors, because again, like, I don't know, probably I should have provided some logic on manually binding event handlers with so yeah, maybe I should have just provide that event handler binding as well. Again, like, before this I had this all this event bindings within the engine itself, but that was forcing the developer to name the engine variable exactly like engine, not something else, because it was hard coded in the engine itself within the GUI part. Just to give you an idea what I'm talking about, just want to quickly show you this. Sorry, let's go to draw board. So here we have this events like on click, on drag, start. Yeah, probably, I don't know, probably I should have be adding this features functionality like on demand. Well, I don't know, it's still an open question. It's very early development stage, so it's hard to say. So anyway, let's just drop back to the initial okay, normal appearance, kind of like, okay, clear, and let's move further on. So what can we do? What can we do here? Well, we can well, I think, okay, hold on a sec. Let's actually keep this, let's keep this instance and not be touching it anymore. And I just now I can reference the internal functions. Okay, so in the browser it should be suggesting all the possibilities available, by the way. But I just want to start with the print board function. So it prints the internal board state, which is exact copy of this one. And let's say, again, now let's quickly walk through, oh, I'm sorry, I don't need calculator. Now let's quickly walk through the API functions themselves. Okay, so yeah, I did even specify the select color being available for changing as the API. Well, probably should have done the same for the main colors. Yeah, you know, like, if no one else but you actually using the program, it's really hard to predict what features would be needed and what features won't be needed. So let's just quickly walk through the constants. So let's start with the version. So if we say engine.version, it prints 1.0. What else? What else? Get rid of this. Color piece. Okay, so if I say engine.color, so we have an object of white and black. So This is needed if we need to specify, if we need to check the color, so whether it's white, whether it's black. That's something that I was doing in the GUI. That's the reason for having this color within the API, so we can reference either like this, but that doesn't really look that great, so we can use this sort of annotation like white, so color to move actually. No, it's not colored. It's just white is encoded as 0 and black is encoded as 1. It's not side to move yet. And black would be this is equal to 1. This is how it works from the inside of the engine. Okay, let's move to the pieces. So if I just say engine.piece, then we have a dictionary of all the pieces available. So these are the piece codes. And again, like the name for pieces in the API are different from those that are available within the engine object. So I'm just using this kind of letters, ASCII letters, to represent pieces, but they represent the codes on their. But this letters represents codes. So we just have a look at. Oh my God, I already closed that. Okay, just forget. So this is the internal piece encoding. So if say we want to put a piece on a given square, we need to use this piece codes. This will get a bit more clear now. Okay, now let's have a look at the squares. So if it's just say engine.square, and we have a list of square codes as well. So this is needed in order to say I want to put white pawn on square E2, something like that. So I hope that is clear actually. Yeah, so let's say if we want to reset the chessboard, I mean like, okay, I will just try to keep things simple instead. Okay, let's move to the methods. So draw board, update board. So these functions are needed only when we need to update the board state. We could have not using draw board, but I'm using that to avoid issues with highlighting, to just erase the previous highlighting and to make the new highlighting being available. And update board actually redraws only the pieces. So draw board, I'm using that only to get rid of the highlighting, and update board is literally enough when you just need to update the board position. Move piece is pure GUI function that is used by the GUI, so I'm not going to be covering it. It's just a specific. Just you better look at it. Have a look at the source code. Flipboard. Yeah, let me demonstrate how the flipboard works. So if I just simply say engine.flipboard. Okay, and now we need to say engine.drawBoard and engine.updateBoard. Now we have our board position being flipped. Again, if we just flip this back again and draw the board and update the board, then we got this board position being restored. Okay, so let's move to the interesting part. So manipulating with manipulating pieces. Yeah. Also, we can convert squares to string. So let's say we have. So I can say engine.square, and let's say square E2. So this is the code of 100. You see it's been pre-coded here. So let's say we want to convert this square code to E2 back. In order to do that, we need to say engine.square to string, and using this, and it gives us E2. The same thing if we just say like 100, it would give us E2. So when we want to set a piece to E2, we literally using this 100 basically. But just for easier using of these codes, we have the back and forth transfers. Like, so this this allows us to convert visual representation to square, and this allows us to convert it back. So if we're getting the square from, say, from the move, and we have no idea, so let's say we have the square from the move string, like from the source square, target square, we have this 100, what that square means. So we know that means E2. Okay, so the next thing to consider, promoted piece is the same like with the squares, but when we want to extract the promoted piece, probably I'll demonstrate this later on, it's very similar. Print board already being demonstrated. Yeah, set board. So this is one of the core functions, so we're using FEN string in order to initialize the chessboard, and I will now just demonstrate you how this works. So let's initialize an empty position. So if we just simply say engine.setBoard and FEN string, well, for those of you who's not aware of what FEN string, you should have googled that. I will now just quickly drag the FEN string. So let's say 8, 1, 2, 3, 4, 5, 6, 7, 8, and let's say Y to move. No castling rights, no in peasant square, 0.50 move rule counter, and 0 of full move counter of entire game. It's impossible position because there are no hints, but that doesn't matter now from the API perspective. So let's just, I think update board should be enough here. Engine. Update board. So yeah, now we finally have an empty board, and if we just print the board to the console, so we have this absolutely empty board. So now let's try to set some pieces to the chessboard, and in order to do that, we have a function called setPiece. So let's start with the setPiece. So piece and the square. So now it would be much more clear why we need those piece and square encoded. So let's say we want to place a pawn on E2. So we need simply to say engine. Sorry guys, been a little bit distracted. So we need simply to say engine.setPiece, and now we need to pick up the proper piece. So let's say engine.piece, and we want to have white pawn. Okay, and the square. Okay, and now we need to specify the squares. So engine.square, and we want to put it on, say, E2. Okay, yeah, like this. Okay, some syntax error. Hold on, guys. Just want to make sure. Yeah, I just don't need this parenthesis, this square bracket. And let's update board. Engine dot update board, and the pawn appears. And if we just print board again, будь здорово. Engine dot print board. Yeah, we get this pawn on E2. So I hope this is clear. Now, if we want to erase the pawn, it's the same as setting a piece, but instead we need to, here we need to say no piece. Just this auto completion makes me a bit nervous. Okay, now we got rid of the pawn, and just again, like so, update board and print board doing the same thing, but print board does this in the console, update board does this within the GUI. So now we just got rid of that. So if we just set our pawn back and print the board and then update the board. So now we need, say we want to say if there is a piece on square E2. So we can simply say engine.getPiece and the square to specify. So we need to say, so well, we can use the constant of 100 obviously, and this is the piece code of the white pawn is being returned back. It's not like true, it's the piece code of the pawn. So let's say if we well, probably it would be a good idea to provide some Unicode representation for pieces like I'm doing here in the console when printing the board, maybe one day. I just want to say, let's say if this was white, I don't know, queen. And this auto completion, why are you doing this? And engine gap piece. So now we have 5, which is the code of white queen. So just to check that, it would just say engine.piece. Engine.piece. So we have 5 means white queen. So I hope that's clear. So this is how we can get the piece from the square. Also, we can get the site and get the 50 rule move counter. Well, this is quite pretty trivial. So site would be 0 for white and 1 for black. 50 rule move counter would be a number. Now we didn't make any moves, so it would be 0. So now let's go to move manipulation, which is a bit more interesting. So let's initialize our position back to the initial one. So let's say engine.set board, and we also have the start fen as the constant, so I can say engine.start fen, and let's update the board. Sorry, engine.update board. So now we have this initial position, and now it comes to making some sort of a moves. So the very first function to introduce is valid. So the idea is very simple. It validates the move and takes the move string as an input, like in USA format, like E2, E4, or B7, B8, queen, things like that. So I'll now demonstrate how this looks like. And if the move is valid, it would return the move code back. And if move is not valid, it would return 0. So let's quickly walk through that as well. So let's say is valid, and let's say E2, E4. Okay, sorry, engine, obviously engine dot is valid. And this is the integer encoded, this is the move encoded to integer. If we want to have a look at this move in the string representation, we can simply say engine dot move to string, and this engine dot is valid and E2, E4, and it returns the string E2, E4. So it's been converted to integer and then being converted back. But this is something that I just wanted to show you how this function works, but this also implicitly done within load moves. So when we want to load either a single move or a bunch of moves to the chessboard, in that case this validation is done implicitly. So we can simply say engine.load moves, and let's say E2, E4, E7, E5, G1, F3. If there would be a legal move, it just drops. It would load until the legal move, and then it just drops, no matter how many on the right. And let's say B8 to C6, and let's update the board. So engine update board. Okay, and we've loaded our game. And if we have a look at the board state variables, this is interesting. This is something that is not represented in the GUI. So we can simply say again, like engine dot print board, and we see that we have 3 full moves. So 1, 2, and 1 move in the initial position. There is always 1 move being set. That's the reason why it's not 2 but 3. Not sure why this is happening, but that's how the things work. And 50 rule move 2, which means only knight moves are taken into account, because pawn moves kind of reset in the 50 move rule counter. So that's another idea to consider. And obviously, yeah, if we just say make a move, so now what's white to move? So let's make move D4. So if I just simply say engine dot load moves, just to show how the single move can be loaded. So D2, D4, and engine dot update board. and engine.printBoard again. So we see now the in peasant square has been set to D3. So if here was a pawn, it could have captured D3, but there is no pawn obviously, so it's not an option. But we still have this in peasant square. If we move a queen, a king, or rooks, it would alter the castle and rights respectively. So I hope that's clear. Okay, let's move further on. So we can also extract the source, target, and promoted piece from a current given move. So let me quickly show you that as well. So let's get back to our isValid. Well, let's actually, well, before anything else, as far as we can now be taking some moves back, I just want to show you. Well, repetition just checks for a single repetition in the position. So if the hash key of the current given position, which is the unique identifier, this one is being repeated within the move list through the game history, that would fire 1, otherwise 0. If you want to implement threefold repetition, you need the repetition counter additionally, so only detects the only repetition at the moment. So yeah, it's nothing to demonstrate here. So it would be true if we import moves like knight here, knight back here, knight back here, and so on. Okay, so what else? Okay, take back. Yeah, let's have a look at the take back. That's interesting. So let's say engine.take back. So we have 1, 2, 3, 4. So we need to say this. So like, okay, let's say take back and update board and print board. Yeah, just need to make sure to reference the engine object. Okay. So take and move back, and it's been taken back all on the way. So this is what happens when in the GUI we're clicking that take back function. That's literally kind of it. So now we're already in the initial position as well. And now let's get back to our move and the matter of extracting source from square, source square, target square, and promoted piece from the given move. So let's say we have a move. So let's say let move equals to isValid and E2, E4, like this. Sorry, engine is valid. Okay, what? Has already been declared. Are you kidding me? Okay. Come on. Now this is very weird. Okay, if this has already been declared, maybe I just can say like reassign it. Are you kidding me? Okay guys, I just have no idea what the heck is going on here. So let's call it, just give a different name to the variable, isValid E2, E4. Okay, finally, and if I have a look at the valid move now, here is the encoded integer. And now let's say we want to extract the from square or source square, target square, and promoted piece, if any, from this move. So that's done the following way. So we can simply say engine.get move source and pass in the valid move as the input. So we have this 100. If we want to convert this to a human readable coordinate, we need to say again like engine.square to string. And we have this E2 being extracted from the move. The same stuff could have been done with the target. So get move target. And if we want to extract the promoted piece, well, this particular example doesn't have that. So instead of square to string, would be using promoted to string, and here get move promoted, but it would give us undefined because we don't promoted this pawn to whatever. So I hope that's clear as well. Okay. Time control is and search is probably something the most interesting thing to have a look at. We'll leave this further on. Yeah, well, in check is trivial. It's quite pretty self-explanatory, so I hope no problems with that. Yeah. What else? Evaluate material draw. So material draw detects whether the insufficient material is available or not. So either 1 if this is insufficient material, or 0 if it's not. Evaluate just returns the static evaluation. Well, let me just quickly show you this. So let's say engine dot evaluate. So it gives 0 because material balance, positional balance. If say we make this, let's say engine dot load moves, let's say D2, D4, and evaluate, it would give us minus 20 from the black's perspective, but this is regardless of the question search. So again, like if there would be the question search done, so it won't be, it would be 0 back again. Okay, it doesn't matter. So that's the static evaluation. Well, just to give you probably a better idea, so let's say engine dot take back, and let's say engine dot set piece, and I just use 0 for no piece to the square of, let's say 0, which means A8. So we just get rid of this root just to save you time typing like engine square and the square engine piece and the piece. So let's say engine dot update board. Yeah, now it gets rid of the root. So if we just call our evaluate again, excuse me, hold on a sec. This is horribly wrong. Shouldn't be like that. Hold on, guys. Well, okay, guys, I just realized why that was happening. Basically, I just need to work out my logic of given penalty for 50 rule move, because otherwise it just gives 0 every time, because if the 50 rule move is 0, then the evaluation behaves quite pretty in a weird way. So well, I can still, well, I just update the stuff here, so to the normal GUI. Okay, just to give you an idea. So let's say we make a move, right? And now let's say let's make also some piece move as well. So let's say engine dot set piece, and now we just get rid of that rook. Now let's go update the board, and now evaluate should give, oh man, it's still, what the heck is that? Okay, guys, sorry, I just really need to figure out what's wrong with my evaluation. Maybe I've just found a horrible bug inside, maybe not sure, but anyway, this evaluate should this function should be returning the static evaluation for should return the static evaluation for the current given position. And yeah, probably I just need to get rid of this. Well, I'm not sure, just really need to make some research, and it always happens like when you try to present something, some horrible bugs appearing. So I hope that at the time when you would be watching this video, the evaluate should be working properly. So we just try to remove the piece from the chessboard. It would return the evaluation respectively. By the way, this kind of like explains some weird behavior of my engine when I was testing it versus other engines. Okay, so material draw, well, actually should be working properly, but it's a bit tricky to set up the position with the material draw. Well, maybe just, I don't know, should I spend time for that? Well, let's try. So let's say engine set board, and let's say black keen, and let's say 6 keen, and let's say night. 1, 2, 3, 4, 5, 6, 7, and 7 keen. Let's say we have white to move. Okay. Engine.update board. This is just an example, so it should be working. And now engine dot is material draw returns 1 because this is the material draw. So if we now just try to add, well, let's say 5 knight and bishop, now it's no longer a material draw. So you see, like, material draw is now equal to 0, just to give you an idea how the updated position looks like. So this is not a material draw, so I hope it's clear. And now the most interesting part is the search and time handling, probably like the most, something that you've been waiting for the most. So let's start with the fixed depth. So here in the GUI, it uses the fixed time search. So you can just specify the number of seconds of how engine would be thinking before outputting the best move. But from the API perspective, we can simply say engine.search and then the fixed depth. Let's say fixed depth 1, have this only move in the principal variation, 2 moves. So this is because of the iterative deepening. So we're not searching the depth straight ahead, but searching from 1, 2, and up to the date that we need. So let's say depth 5. This is how it happens basically. So I hope this is quite pretty clear. But the more interesting thing is how to set up a time control properly. That is something that is done by the Arena GUI when the engine is working with the UCI protocol. But that's a bit more complicated because we need to take care about things like white time, black time, white increment, black increment. So here I'll just simply show the core part of how we can switch between search for time and search for depth modes. So let's clear the console, and I just want to say, well, let's say engine. So there is the function. Yeah, let's create a variable. So I call it timing equals engine.get time control. And if we just have a look at our timing variable, so this is the dictionary, or it's from the Python perspective. In JavaScript, this is called object. So time -1 and time set 0. So as far as time is equal to -1 and time set is equal to 0, engine would be searching for a depth given to it as an argument. So say engine.search and then whatever depth. So something that I've shown already. But now let's say we want to search for some particular amount of time. So first we need to say, first we need to ingest this object. So time set should be equal to 1. So this is the first thing to consider. Then we need to say time. Well, let's go like this. Then we need to say time. Well, it's not needed to be done that complicated how I'm doing this now, but that is how it's done within the UCI protocol. I'm just reusing the logic from there. So time and time equals, let's say 3,000 milliseconds or 3 seconds, and then we need to say so also we need to say the start time. No, start time. Yeah, let's say, okay, time in dot stop time. So this is where it should stop. And here I'm using this new date. Well, no, let me just show you this a bit in a different way. So this is the updated timing. So we have time control. So search for time, not for depth. This mode is equal. Is enabled. How long to search time. And now we need, in order to make sure that it would be searching for 3 seconds, we need to adjust this. Not the stopped, but the stop time variable stopped is just the internal flag that is used by the engine. So let's create a variable. So let's start time equals well, hold on a sec. This would be, yeah, this would take time. Hold on, guys. I just want to have a look. How did I manage this in my API example? I was doing this just this morning. Oh man, if I could only remember how I done that. Okay, I just tried. I'm not sure whether it works or not. So let me just try. So get time and time and dot stop time equals start time plus, hold on a sec. Why did I create this time and dot start time? This wasn't necessarily needed actually. Yeah, I need, yeah, I'm just finding too many bugs here. Anyway, that doesn't matter, Start time plus time and dot stop time. No, start time plus time and dot time. Okay. Oh man, I feel totally lost now. What do I... Okay, what if I just grab this snippet? What if I just grab this entire snippet? Oh yeah, that's the matter of being... Yeah, we just need to execute this instantly. Yeah, that's the reason, because otherwise the time when I'm typing the code is treated to be the search time. Okay, just forget that. This just needs to be done instantly. So I will now run the code, but before this, let me quickly walk through this. So yeah, I just don't need to create to make time in to make start time the part of time in here. This code just needs to be. I need to run it instantly, like all the party. I can't do this one by one. So the first thing, we're getting the current time control from the engine. So that time in object that I've been demonstrating. So we're enabling the time control, so it's kind of taking into account the fact that we're searching for a fixed amount of time. Here we define the current time in milliseconds. Then this is the offset, the time offset to think for. So let's say 1 millisecond here. Then we're setting the stop time, which equals start time, whatever was there at the moment of creation, plus 1 second. So it would be thinking for 1 second. And then just bring the time in, we'll see this. Then we're calling this set time control to enable this time in, to apply this time into the engine's internal time in object. And then we're calling this engine search, and 64 it's kind of like the max depth to search. So just to make sure that it would drop back from the search before reaching the depth of 64, which would take really ages. And then just for comparison, I'm making this reset time control. So after resetting the time control, time set would be equal to 0 back, and time would be equal to -1, and it won't be taken into account this time control. So none of this would be available after resetting the time control, and then it would be just going for the flat 6 splice search. So let's have a look. Oh man, timing has been already declared. Okay, just update the stuff and try again. Okay, so this is how it works. So this was the initial timing. After we've set this up. So start time, stop time. Well, again, like this start time doesn't obviously it's not a part of the timing. I did it so, but doesn't. Yeah, just run. Sorry guys. Okay, just to prove the concept. Let me just get rid of this. We don't need this. Just should be working. Yeah. Start time is not a part of the timing structure. And stopped equals to true means that hold on a sec. Yeah, because it was stopped within the search. Yeah, probably. Or no, it means that it's not yet stopped. Okay. So the idea is searching only for 1 second. And then we just go for a fixed depth search back, searching for 6 splice. So depth 6, and here depth 5. That's all we managed to search within the within the time frame of 1 second. Okay, let's just. Yeah, I already need to check really lots of things after this video. So let's give it kind of 5 seconds, and let's not doing this flat search. So let's just. So now it would be thinking for 5 seconds. So 1, 2, 3, 4, 5, and it outputs the move. So this is the idea. So again, like we need to make this, we need to calculate the time to stop, which is start time, plus this offset. Well, actually, we could have even not set it up this time. This is, well, probably it should be working even without that. Let me just quickly check that. We could have make it like let's have 3 now. I just used the extended example from the documentation. So time set equal to 1. Yeah, this should be searching for 3 seconds and then drop. Yeah, and it does so. Yeah, and it just researches to. Okay, nope. Oh man. Yeah, now I understand why people just provided the documentation on making these tutorials. Oh, okay, just forget this. Just forget this, okay. Okay guys, just hope to make this one last time because I'm already getting nervous. Just want to show a more simple way of doing this. So this should be done in a couple lines of code. Yeah, we need to set up this time set because otherwise it won't be working. Yeah. So now it should be searching for 3 seconds. 1, 2, 3. Okay. So yeah, it can be done easier. So only setting the time set to 1 and then just specifying the value for a stop time. The reason why I'm providing all of this, the reason why I'm making this in such a complicated way is that's exactly how it works within the UCA module of this WukongJS engine. So man, how to get away from here? Okay. This is what am I talking about? So I'm getting the time control, and then I'm initializing the time because I'm parsing the time. That's why I use that. So if you just want to make it once, you don't really need this. So again, like it's on your own how in particular it's supposed to be implemented this time and stuff. And the very last thing for, well, okay guys, I'm just really tired. I feel already tired at the moment, to be honest. The very last thing to demonstrate is this checkmate detection. So I just quickly copy paste the snippet I've created just to give you an idea. Okay. So copy this and let's make an update, paste. Well, you can actually just copy paste this API snippets from here to the browser console and see how the result works. So we got this checkmate. So this is the checkmate. So also we have this in check state which is equal to 1 actually. So I hope that's quite pretty clear. Well guys, so this is it from my side. I don't know whether you have liked this Wukong API crash course or not. Just really want to hear your feedback in the commentaries. So until the next time, and take care.